Hello world, I'm Joanne and this is the Frizzle Factor. Today with our lesson prep, I wanted to talk about morphology because it's something that I think is implicitly in a lot of topics that we cover, especially in a biology or life science classroom, but maybe we are not as aware of it explicitly. And I think it's important to think about because ultimately, I think one thing that undergirds studying morphology, that is kind of the physical nature, the physiology and anatomy of a creature or of an organism, is that shape ultimately determines function. And this is a helpful mantra that I think is helpful to thread throughout your studies and your teaching through biology and life science. So, for example, I'm going to be talking about two different things that seem unrelated, but they still carry this idea of morphology and why I think we should be using morphology more in the classroom, because I think it's helpful for understanding not only natural history of larger macroorganisms, but also understanding the function of smaller things, as we'll talk about. So one thing that is, I think, the more obvious application of morphology is studying the natural history of different organisms. So you can know a lot about an organism just by how it looks. And I think this is very important for people to know generally as a skill, because it helps with not only identification, but also just understanding and contextualizing the things that we see around us. For example, one of the things, I'm looking at my notes, for example, one of the things that I think is really helpful and that I have done is actually using fish to kind of show this skill. So I really like focusing on native organisms, and one of the things that I have done is curate a list of native fish in my state and region in order to get students interested in morphology as well as taxonomy and phylogeny. And I'll talk more about taxonomy and phylogeny in another video, but at least for right now, you can know a lot about a fish by just how it looks. One of my favorite fish is the Alabama hogsucker. If you look at the Alabama hogsucker, you know that it's not like the normal fish you catch in a lake, because it has a very specific function. A lot of how it looks, so the way its mouth is facing, the way its fins are shaped, the color of its scales, all of these different adaptations are vital for understanding what this creature actually serves in its ecosystem. And you don't have to know anything about the Alabama hogsucker to know the kinds of things you should expect from how it serves its ecosystem. And so I think it's great to show students the differences in anatomy, the differences in morphology of these different fish, because it starts to get to this idea that their shape determines their function. So you can also apply it not only just to the current lifestyles of these animals, so you can know how it lives if you're here right now presently, but this also applies even to thinking about fossils. So we can then, using our knowledge of fish right now, using our knowledge of the fins and the gills and what it looks like and their shapes, we can look at a fossil of a fish-like creature from millions of years ago and see that it has similar elements. And so we can use reason and logic to see, okay, well, we know that these sucker fish, the mouth faces downward, probably because it tends to eat things that are on the bottom. It must be a bottom feeder. So if we find a fossil from thousands of millions of years ago that shows this downward facing mouth, then perhaps we can assume a little bit about its natural history and what it does to live, so what kinds of things it might eat. So I think these are great things to show as far as thinking about, like, well, the clues in the world around us about what an animal is like. This could be interesting for animal behavior, so you could use morphology to understand animal behavior. You can use morphology to understand habitat preferences. You can use it to understand niche. You can use it to understand adaptations. You can use it to understand evolution. You can use it to understand a lot of things when it comes to organisms. And not just animals, but people too. So there are parts of our bodies, our morphology, that make sense of how we live and act, and also makes sense of us as, I guess, a society, as creatures, as humans. And so one thing that I think is interesting to explore is how we can take this even a step further, of not just looking at like the macro creature, but going even smaller. So morphology, shape determines function, is such a vital thing in biochemistry. Yes, I made that connection. We just went all the way from like natural history, evolution, ecology, to biochemistry, because biochemistry is often underserved in biology classes. We talk a lot about chemistry. We talk in more broad strokes about the macromolecules, so students definitely get this idea of proteins. But one of the things that I think must be every teacher's attempt to have a takeaway. So every student, I believe, should have this takeaway from biology. They should know that proteins, when it comes to proteins, shape determines function. That is going to be one of the most helpful things, especially when you get a kid that has to go on to organic and biochemistry. Biochemistry, shape determines function. It is so helpful to realize that with proteins. So one thing that I have done in the past, and I'm working on maybe curating this better, but I've had basically a little exercise where I call it pennies to protons. And I don't know if I'll use pennies in the future, but this is just a good idea that I'm sharing with you that you can maybe exemplify to your students in some way. I had two containers. One was like a broader, it was basically a piggy bank that was able to have, it was a cup that was a piggy bank that was able to have multiple size coins fit into it. So basically anything could fit into it. And then I had just a normal slit piggy bank that could only fit like dimes or something like that. It was very specific what kind of coin it could fit. And so what I did was I had a rotation activity where I was going through several aspects of things that cause disease, and that was the context of this. And so I did focus a little bit on prions, and I thought that was kind of interesting because prions are essentially proteins that are misshapen. And so the interesting thing about prions is because they're in the wrong shape, they no longer serve a proper function, because once again, shape determines function. And so when we're looking at the morphology of proteins, it's actually really important to understand that in order to understand how they operate and how they work. And so what I did for the station was I had these two different kinds of piggy banks, one that was selective and one that was not. And I used those as the substrates, and the coins were basically the proteins that were specific to a specific substrate. But of course, the one that accepted just anything was misshapen and didn't really function in the way that it was. And so that was kind of a cheesy, overly simplistic way of thinking about how prions are a protein that isn't shaped correctly. And so therefore, a lot of issues happen. And there's still more research being done on that because it's kind of a new, interesting area. But I think that's just something to think about, that when we think about morphology, it applies not just to the big things that we see about like trees and animals and us, but it also applies to things that build all of these things like proteins. And so it's really important to understand this idea that, again, shape determines function. So I hope that this is just a little thing that can help you maybe to recontextualize how, or the emphasis of some of your lessons. And maybe throw this in there because it's a great mantra, because it's really helpful and it goes across many subjects. And even though I don't quite have the pennies to protons activity finalized, I will share some resources that helps me think through prions, and I think they're a really cool thing to focus on when you're thinking about disease and what causes disease. That's just a fun kind of forefront science thing to know about, so I'll share some resources that I think are fun with that. But also with my fish idea that I alluded to, I do have an activity where I had students look at different native fish, and using those as a model, I kind of had them explore how the different shapes of their mouth and the different shapes of their body can tell us about what they're like. And I had kind of an activity where I had students make just a cheesy morphology related assessment where they had to make basically a dating profile, or at least a social media profile for their fish, where they had to imply through talking about its hobbies and where it lives and what it likes to do, it had to imply its life history. So they had to basically think about, well, if it's a long attenuated, so pencil-like shape, then it's going to be some sort of sit-and-wait predator. So they had to maybe think about where they would take their date on to eat, right? To think about how they would go hunting. So they had to maybe be creative and do that. It's a little cheesy, but it's a good tie-in, a one-off kind of introduction to morphology, and I would often tie this later with thinking about taxonomy and phylogeny. I bring up the fish cards that I use for it again because I want students to kind of familiarize themselves with some of our native species, and also when they see them again, it's like, aha. And so when we start going through taxonomy and phylogeny, they're more able to think their morphology can help them identify the relationships between these animals. So that's a cool segue. And I'll provide those resources below. Thanks. If you have any cool things to add, things to talk about, fun facts about prions and or fish, let me know.